We've begun talking about our solving linear systems unit on Friday by reviewing how to graph lines. And when we're solving a linear system, what we're looking for is the point where the two lines intersect. In other words, the point that makes both equations true. Now, the reason we want to do this is because this actually has a lot of real life implications in terms of solving problems. And usually in the real life, the numbers just don't appear. You have to actually create the numerical equations, the mathematical equations, in order to solve them. So here we have a review of some of the words that mean that we will need to add or subtract or multiply or divide or equals. So you can take a look through there. It's certainly not an exhaustive list. There are probably more words that we could add. These are just words that I've collected over the years from students as we've gone through this activity. So take a moment, check your list with what I have here, see if there are things that we need to add. If there are, please let me know and we can add those to it. Okay, now we are actually going to start using this information to model the following problems using let statements to indicate what the variables represent, and then give the two equations. And then you're going to use your Desmos, your graphing technology, to solve each one. We're not going to solve these by graphing by hand. We're going to get you to use Desmos. You tap on the intersection point and it will come up with the coordinates, and then you interpret what the coordinates mean. Okay, so here we go. We need to in this case we have the sum of two numbers is 249. So right away in my brain I'm thinking that sum means to add, and I have two different numbers. So I'm going to let x represent, and sometimes it takes me until I read the whole problem, but I kind of jumped the gun on this one because I knew what I was doing, but I would read through the whole problem first before starting this. Let x represent let's go with the larger number. And then my other let statement will be let y represent the smaller number. And it's the value that I'm talking about here. So there's my let statements. And then I want to come up with the equations. I know that I want the sum. So the word sum here means to add. So I want to add the two numbers, and the is the equal sign. So my two numbers are x and y, and I want to add them together. So x plus y equals, or is, 249. So there's my first equation. Now, the next part says twice, and if you look at our list above, twice means two times. Two times the larger number is the x, plus three times, so three times, the smaller number is y, so that'll be y, is 591. So you can see by reading the words and interpreting them into the math, the equations can come fairly easily. Now some will get more challenging as we go along, but for the first little bit they're not too bad. So there's my two equations, and then I'm going to open up Desmos on my iPad. I'm going to type those two equations in there, and I'm going to find the point of intersection. Now, I don't have my Desmos right in front of me, so hold on a moment. Okay, so you should be opening up your Desmos, and you're going to type these equations in as you see them. And I had to adjust my screen to be able to see it, so I pinched my screen in so that I kind of zoomed out on the axes. I got out to like 500 or something like that. And then what I did is I tapped where I thought the intersection point was, and a little gray dot appeared. And then I tapped it again, and it showed me the coordinates for the intersection point. And what it came up with was 156, 93. Now, in terms of my letters, this is x and this one's y. The 93 is the y. So that means then that my larger number has to be 156. Since my y represents the smaller number has to be 93. So when we're doing these problems, then we would finalize that with, therefore, and you can use the three dots there, the larger number is 156, and the smaller number is 93. And there we have the first problem done. Okay, in question number 2, it says two numbers have a difference of 9. 3 times a larger number is the same as 7 less than 5 times the smaller number. What are the two numbers? So I know I need to find two numbers. And the question talked about a larger number and a smaller number. So once again, my let statements are going to be very similar as the previous question. We could let x represent the larger number, and we could let y represent the smaller number. All right, and now we are going to start developing our equations. We have two numbers that have a difference of 9. Now the word difference means we're subtracting. If we take the larger and take the smaller one away from it, we should have an answer of 9. So we want the larger number, which is x, take away the smaller one because the answer was positive, and that is equal to positive 9. And then it says 3 times the larger. So this is 3 times. I have to multiply. The larger number is x. Is the same as, so same as means equal to. So we've got 3x is equal to 7 less than 5 times the smaller number. So I want 5 times the smaller number. So they're not quite equal because the 3 times the larger is the same as 7 less than 5 times the smaller number. So if I did 5 times the smaller number, I have to go 7 less than that to have it equal to 3 times the larger number. So hopefully that makes sense. Now what I'm going to do is put those equations in Desmos, and we're going to find the intersection point. So I'll give you some time to do it. Put me on pause. Okay, when I graphed that on Desmos, I ended up with an intersection point of 26, 17. So my larger number is 26 because the x was the larger number, and the y is the 17 because y came second. So we would write a final statement where we're interpreting our results. Therefore, the larger number is 26 and the smaller number is 17. Now, one thing to note on Desmos, if you end up like zooming out and getting a scale that's really crazy and you want to go back to just a 10 by 10 by 10, 10 by negative 10 kind of screen, in the corner on the top right-hand side, there's a little house. If you tap that house button, it'll take you back to the negative 10, 10 kind of screen. Okay. Now, the next question is a money problem. So the first two were number problems. These are kind of like types of problems that you're going to encounter as you do your questions. Money problems. A kiddie ride at the mall only accepts loonies and toonies. So we're talking about money here, and it's loonies and toonies that we are talking about. The ride had $96 in it. So $96 is a value of the money. And then with a total of 70 coins. And then how many of each coin are there? So this last sentence is really telling me what I want my variables to be. I want to know how many of each coin there are. So how many loonies there are and how many toonies. So when I put my let statements in, I'm going to let T represent the number of toonies, and let L, I hesitate to use L only because it looks like the number 1. If I had cursive, if I was just writing this in my own handwriting, in fact, maybe I can do that. Represent the number of loonies. I love autocorrect. I just noticed that they called it the tooniest. I didn't think I meant to do that. I'm not sure if I actually typed it correctly or whether it was autocorrect, but it's kind of, yeah, the number of toonies. There you go. I think it autocorrected. All right, so let L, and I'm going to do a cursive, try and do a cursive letter L in there. Okay, so that it doesn't look like a number 1. All right, now let's put the pieces together here. I'm going to start with the easier part. There were a total of 70 coins. That means if I take the number of toonies and add to it the number of loonies, altogether I would have a total, add together, a total of 70 coins. So the number of toonies, so T plus L, and again, I'm using a cursive T so it doesn't look like a plus sign, has to equal 70. All right, the number of toonies plus the number of loonies is 70 altogether. The other piece that's in here is that the ride had $96 in it. Now, $96 is actually the value of the loonies and the toonies. I know a loonie's worth $1 and a toonie is worth $2. So if I take the number of loonies I have, that will be how many dollars there are. But if I take the number of toonies I have, let's say there's 5 toonies, it's actually worth $10. If I had 20 toonies, it's actually worth $40. The value of my toonies really is 2 times the number of toonies. And your loonies are really just 1 times the number of loonies. And you don't have to actually write that 1 in there, but I'm just putting it in there so you can see it. When you get to nickels and dimes and quarters, you want to put like 0.25 in for your 25 cents for your quarters, or if it was dimes, it would be 0.1. If it's nickels, it's 0.05. So that's what we do with the money problems. Now put me on pause, put that into Desmos, and see where the solution is. Now you could go to the alphabetic keyboard to do this. I just actually made my T be the X and my L be the Y, and then my point of intersection that came up was 26, 44. So that for me, since the X I used as my T, that means I have 26 toonies and I should have 44 loonies. And if you add those together, you do get 70 coins. And if you did the math, 2 times the 26 plus 1 times the 44, that does equal $96. So we know that we got our answer correct. It did work out, made both equations true. And then we put our therefore statement in. Try the last question and then check your answer after.